would like to thank the team at Hexagon and Solize India to give us the opportunity to host the event for our readers. There are many, many challenges that electric vehicle companies face while designing a new product. And in this session, we would like to highlight those aspects. We would like to gather the view of our leading industry practitioners on the panel and understand their approach towards solving these issues. We have an expert panel who will present their perspective on the subject and share insights from their experience of developing and putting products into the market. We will also explore how digital tests and virtual simulation tools can be used in different stages of product development lifecycle and how they can help the OEMs tackle some of those challenges in an efficient manner. So let me start with a quick round of introductions of our panel members today. On the panel, we have Dr. Dev Mukherjee, who's an automotive expert and managing director at Omega CK Mobility. We have...
Hello, Priyakshi.
Hello, sir. Thank you. We have Mr. Bhavneesh Athikari, Senior Manager and Automotive Lead at Hexagon for Indo-Pacific region. We have Mr. Shresht Mishra, co-founder at Simple Energy, and Mr. Mansin Kumbar, who is the founder at GCAMS Technology. So welcome, gentlemen. Thank you for making time for this panel today.
Thank you.
In terms of event itinerary, we are going to start with a panel discussion on e-mobility design and manufacturing challenges. And post that discussion, we'll have a quick presentation from Bhavneesh on how upfront simulation and digital tools can help us solve some of those challenges. And this will be followed by audience Q&A, and we will wrap up the session by 4:30 p.m. So if you have any questions at any point during the session, please feel free to put those in the Q&A box, and we will try to take them in the Q&A session towards the end. So without any further delay, I welcome you all again, and we'll start with the panel discussion on e-mobility design and manufacturing challenges. So my first question will be to Dr. Mukherjee. And sir, we would like to understand from you what additional challenges does electric vehicle design have when you compare it to regular ICE vehicle design, and what is the design philosophy that Omega CK has taken to design its product?
Yeah, Priyakshi, thank you very much, first of all, for having me in the panel. And I would like to thank Hexagon and Solize for organizing this discussion. You see, EV is a new, phenomena in the automotive industry. Auto industry in the IC era has gone through a lot of iterations, changes, modifications, upgrades, etc. throughout its life history. And we have seen it, particularly last 30 years or so, during my lifespan in the auto industry for the last 35 years, we have seen life cycles, the product launch time getting squeezed. Earlier it used to be 5 years, then it became 36 months. Now it is about 18 months or so. So, it is still very high as we talk about the EV industry. But this is how IC engine improved. The vehicles became safer, faster, lighter, more fuel efficient. On the emission side also, there were a lot of improvements. So, but those were kind of, I would say, incremental improvements. And also the IC era per se, the OEMs took a long time to perfect these technologies, going through a lot of testing, validations, life cycle testing, etc., etc. That's the kind of culture that was there in the IC era. I'm not saying whether that was good or bad. I'm not commenting on that, but that is how the industry kind of, ran. Now coming to this new age industry of electric vehicles, now things happen fast. First of all, there is people are in a hurry, which may be good thing, may not be good thing in certain areas. See, as far as technology maturity is concerned, I think you need to be sure before putting a vehicle in the market, because it is not something which is mounted on in a room or just in a stationary application. This is a vehicle which has to run 100, 200, 500 kilometers in a day in different conditions. Also in India, the conditions vary. Region to region, place to place, etc. So I think the challenges are, first of all, understanding the the behavior of the vehicle in different running condition, the usage pattern, the traffic, the idling time, for example, it is not there in other parts of the developed parts of the world, etc. So I think the technology has to keep these driving condition, usage pattern, driver habits, also the climatic condition, ambient temperature, humidity, etc. into mind. And these, lot of these data may not be available in the context of EV, for example, and people are now realizing. So I'm not saying that we got to burn few more scooters to understand the impact of heat. That is not the right way. These can be simulated, and also the OEMs need to capture these data, as much as data points as possible, and then find out what is the best fit for them in terms.
Dr. Mukherjee, we lost you there. Can you hear me, sir? I'll have my colleague check with Dr. Mukherjee. In the meanwhile, let me come to Shresht. So Shresht, I will start with, I think, one question that I'm sure everybody is asking you. So the question is, what is the current market readiness of simple energy scooters, and when are the test rides going to start? Shresht, you are on mute. Please unmute yourself.
Thank you, Priyaksha, for having me over. And sorry, I'm not feeling a little well because of the rains that keep happening in Bangalore. Thanks to that, a little bit of cold. So I beg your pardon for that. And apart from that, the test rides will start very soon. In the next couple of months, you will see the test rides and the vehicle on the road as well. And Dr. Mukherjee was saying, definitely India as a country is a very huge country in terms of population, in terms of size, and the temperature and the road conditions, driving conditions, everything vary from place to place. As the temperature ranges from 0 degrees Celsius to sometimes 50 degrees Celsius as well. And no matter what the regulations and the government say that you can only ride 2 people on a 2-wheeler, but people tend to go 3 and 4 people as well. So all those things have to be taken into consideration while designing the products. And what Indian market majorly has is products parachuted from our neighboring country and rebranded and sold. So that is something that we need to understand, that those products are not designed according to the Indian use cases, Indian conditions. So that needs to be taken into consideration before putting the vehicles on the road. Because when you're talking about electric vehicles or any kind of vehicle, automotive, it has a capacity to injure people seriously and sometimes kill as well. So we have to be very sure before putting out a product in the market. It has to be tested properly, validated. Designing, developing definitely is the most important part, because R&D is a solution to all the problems that we have right now. But apart from that, testing, validation is also a very crucial part. So that is where the softwares and the companies like Hexagon come into picture and help us out, startups like us or any other companies, to shorten that timeline to go to the market, where we had to build almost 500 prototypes in the past. Right now it can be reduced to, let's say, 50 or 100. So that is where all these things come into picture. So as definitely what Dr. Mukherjee said, I completely agree to that.
But after the recent fire incident sort of shook up the industry, was there any pivot at all, any change in the overall approach you are taking to safety aspects?
So yeah, so when we started designing, developing, so from day one when we started, we were very sure that we want to design, develop, and manufacture things in India in our own company. So we have taken all those parameters into consideration. What are the problems that others are facing, and the temperature ranges that are there, and all those things. So we are focused on that front, doing R&D on different aspects, working on advanced thermal management systems for the battery packs, for the motor controller, in order to keep the temperature in control, so that the vehicle performance is also not affected adversely. So yeah, definitely those things are in the market, but I feel electric vehicles have come into the limelight right now, so people are more focused on that front. But other than that, I feel IC engines, we are talking about IC engines, we are literally riding a petrol tank, right? Petrol tank that is highly flammable, even more flammable than when we compare to the electric vehicles. So that is there. The safety concerns are there, but these needs to be OEMs and the government as well. So all the things together, when the OEMs and the governments and the regulatory authorities come together and make a set of rules that all the companies need to follow, and with the time it will evolve. So the safety concerns will be solved.
Okay, thanks. Bhavnish, next I'll come to you. So like both Dr. Mukherjee and Shresth have talked about how digital tools here can help to be more sure about your product and do the R&D that is required before you put a reliable product into the market. So can you go into a little bit more detail and let us know how the safety challenges can be specifically addressed through digital validation?
Thank you. Good afternoon, all. So from our car's point of view, we are moving more towards, it's becoming more of electrical and electronics and less of mechanical these days. And that poses a little, and more so in electric vehicles. So that poses a new challenge of, the safety regulations, what we are having today, is it good enough? And the validation, what we are doing. So from a digital validation point of view, what advantage it gives you is it will allow you to assess or validate the performance and the quality of the products upfront in the design cycle. That allows you to innovate your product upfront in the design cycle, whereas in physics, it cannot completely replace your physical testing, but it has to help in a way, like Shreyas said, it reduces a lot of protos and also the cost of the product, but at the same time, it will help you innovate and come up with the innovative solution upfront in the design cycle. As you know, that with the maturity of the design, the changes become more difficult and more costlier. So at the early design phase, the amount of information what you have about the product is very limited because you don't have a physical proto of it. So that is where simulation can play a role. So simulation can help you give that information which is lacking. And with that, we can take an informed decision to build a great product.
Right. So thanks. Thank you for that, Bhavanish. Mr. Kumbar, if we talk about, again, EV design specifically and how it is different from how the ICE, or unique, we can say, how if we compare with how ICE vehicles have been designed in the past, because the dynamics are different, the powertrain is different. So does that also introduce any additional challenges with respect to NVH or acoustic parameters?
Well, good afternoon, everyone. I take this opportunity to, of course, try to get into the critical points of IC design versus electric vehicle design. And as everyone see, the globe is gearing up fast for the EV. At the same time, then we saw some unpleasant articles as you highlight, etc. So there are two aspects in electric vehicle design. In IC design, which is multiple decades old technology, which was evolved over, let's say, 100 years. And that's when we matured in order to performance of the vehicle, in order to the security of the vehicle, safety of the vehicle. As far as EV is concerned, we are in a rush, as some people said. And the first approach, of course, most of the OEMs are taking is to convert their current existing product into EV product, and not necessarily going for the new from the scratch products meant for EV. So that's a bigger challenge, which to integrate electric vehicles into current structures, body, frame, suspension, in order to make incremental changes and get a faster electric vehicle. The electric vehicle inherently has the motor, battery, controls, etc. And the operational principles of electric motor, as well as the transmission, etc., is at a different dynamics. It needs to reach at very high frequencies in order to tackle with NVH, in order to tackle with any other performance issues. Typically, motors are running at very high speed, and you have to get them down and increase the torque. So the current infrastructure in the vehicle, which is being meant for IC engines, is typically not supporting well these dynamics of the powertrain, e-powertrain, I would say. And that's where the performance has been not to the level where we expect. Similarly, packaging constraints and packaging demanding aggregate in electric vehicles. As at the same time, you want to pack a lot of energy into small space with high density. And in the current vehicle design, you want to ensure that the thermal management is achieved so that the temperatures doesn't go up. So that's been a big challenge. And then there are the new fresh EV vehicles where you start from the scratch as EV vehicles, for example, Tesla or somebody, where the challenges would be to make sure that your vehicle is very really value adding vehicle, where the weight is less, the cost is less, because you want higher ranges, you want good serviceability, you want low temperatures. So basically, value engineering is an aspect in the new vehicle, electric vehicle from scratch. So I see that the design philosophy for electric vehicles has been evolving. Nobody is expert in it, but I think the simulations, of course, is the key to go into micro aspects of the battery, micro aspects of the motor, transmission, in terms of noise, in terms of thermal management, in terms of durability, the transients, vibrations. So it needs to focus on simulation because there's not predecessor information available.
Okay, thank you. Thank you for sharing that, sir. So from design, if we come to the next step, that is manufacturing. So Dr. Mukherjee, we see that many companies these days, they come up with a prototype, the products are announced, but then we find there are either those products at many times do not come to market for 3 years, 4 years, or they come very, very late. So what is the underlying phenomena behind this? What are the manufacturing challenges specifically for electric vehicles? Dr. Mukherjee, are you
Yeah,
there?
sorry, Priyakshi, I didn't get.
Can you
Can you hear me? Can you hear me?
Yes, sir, we can hear you.
Yeah. Sorry, please repeat the question.
So my question is that we see many announcements and prototypes in EV domains, but the products do not end up reaching the market, or they come to the market very late than announced. So what are the underlying manufacturing challenges? Is it just the rush for the companies to announce the products, to create a hype? That is the reason here, or there are significant challenges with respect to manufacturing that electric vehicle OEMs are facing that results in all these delays?
Well, you see, I don't want to comment on the companies making wild announcements and all that. I don't want to get into that. That's a separate debate. But the point I'm making, see, every company makes its own strategy in terms of marketing, business, sales, promotion, product introduction, readiness to market, etc. So that's the individual company's strategy. Somebody wants to make a big bang announcement and does it. That's their sort of strategy. The point here is that there, in automotive, it is a very complex supply chain, right from product design, development, testing, validation, homologation to hitting the market, and then after sale, and also now going forward, the end of life treatment also is coming into play. So I think it is a combination of several links of the entire chain which have to be put in place if you want to enter into a serious business. If you just want to do it in a shortcut and ready to rush to the market and raise some money and excite the investors and all, I have no problem with that. That's a great business model. I'm not saying that there is something wrong. So but that is their business model. But an OEM which is looking at a strong business model for a long term business, then you have to put all these different links of the chain in place, and that is where the readiness of production, supply chain, localization, local manufacturing, and scale up comes. Okay, you can maybe buy few containers from China and put it in the market, but I mean, if that is your business model, so that's a quite an opportunistic business model. And people who are doing it, they are doing it. I have nothing against it, or that is their business model. But if you want to become a serious OEM, then you got to have this technology maturity, business readiness, and also it needs investment at every place. You need people, you need systems in place. So I think those are the challenges. The local manufacturing, for example, there is a supply chain issue, as we all know, because the electronic parts are not coming, chips are not coming, and there are several shortages. So you need to have a robust supply chain in place to reach a certain level of production. But if you want to have that import and sell kind of trading model, then it's okay. You can sell for a couple of months, then sit quiet, and next, when the containers arrive, then you sell again. And that's basically then it's a trading model. But for a local manufacturing, several links have to be put in place. The foundation and a robust IT system has to be in place to manage the entire supply chain.
True. Yes, sir. Understand. And we see, because there are a lot of startups that have entered the electric vehicle space. So I understand that manufacturing is all the more challenging for a startup rather than maybe an ICE company that already has manufacturing experience, have deep pockets. But Shresth, for someone like you who has started from an electric powertrain, for any startup, the cost efficiency and the ability to scale the manufacturing setup to the future needs should be a big concern. There has to be a fine balance there. So how did you solve it? How did you go about planning your manufacturing setup?
So yeah, so when we started, we were very sure that we would want to design, develop, and manufacture all the components in-house, be it the motor controller, battery pack, BMS, everything. Sorry. So when we started, so that is what it is. It definitely takes a lot of money, because when you talk about hardware startups or hardware business, it's capital consuming. It demands a lot of capital. And when you're building the right product in the market, you would get money in the market. I guess everybody would agree to that. When you go out, when we have a very good example of Tesla, Rivian, all those companies who have started from zero, but still they built a great product and they got good money from the market, and now are competing with the existing OEMs like Ford, GM, and all that. So yeah, but again, when you start, it has to be very specific that how you want to plan it, because hardware is again very capital consuming, as I said. So the software side as well. So the companies that I guess Bhavani would agree to me that the software costs are very high. But in order to get to a product and reduce the cost that you'll be burning on the physical prototypes, you have to spend that. So you have to prioritize on getting the right software, partnering with the right companies, and building a right team, which can help you reduce that cost as much as possible and take the product to the market. So it's just that what you want to do and how you want to do is very important. So the company's vision should be clear that what they want to do, and then you have to walk step by step, take every single step to get there. You might face challenges in start, but as you go forward, you'll feel the heat as well. But again, it's about sticking to what you started for and where you want to go. That is what will take you forward.
Right. So when you planned for Simple Energies, I'm sorry if in case you are not able to take the questions, I understand you're struggling a
No,
bit.
it's fine. It's fine. It's completely fine.
Okay. So when you started planning for Simple Energies manufacturing setup, so how do you have a big vision in mind? Like, do you acquire the land accordingly as per your 10 years vision, or do you want to start really small and then see what the market response is, and then you plan for a bigger setup? What is the philosophy that you have gone after?
Yeah, we will be setting up our manufacturing facility in 2 phases. One phase will have a capacity of 500,000 vehicles that will cater to the existing market. And as the market matures, the demand increases, we'll be able to scale up our production to almost 1 or 2 million scooters. And then as the market requires, we will be scaling up again. So that's the continuous process. It's a step-by-step process, not just building a factory that can produce 10 million scooters a day, a year, but also looking at the market demand, what is there.
Right, that's it. So Bhavnesh, can simulation, any tools help with planning manufacturing setups as well, like after design?
Yeah, definitely. So today, if you look at the manufacturing processes, may it be welding or forming, various other, even the latest one, additive manufacturing, it's mainly done with the trial and error approach, or with the experience or the skills what the people have in the floor. What value these softwares can bring in is they'll be able to give you what is the right parameters which need to be set upfront, so that you have first time right manufactured product. So to give you an example, let us take an example of a frame which is welded together. So some of the quality issues with that when it's welded is the distortion of the frame. It distorts because the where you clamp, how you weld, the weld path all defines on how it's going to deform. So mostly today it's done with the experience in the flow, but softwares can help you to optimize the number of clamps. That the number of clamps, when it goes down, it also brings down the cost. And also these distortions, residual stresses can be addressed upfront in the design cycle by planning for your manufacturing in the digital scenarios. So yes, so that's one such example. You can take the latest the new manufacturing technologies like additive manufacturing. So same issue, when you print it at what orientation, what's the support structure, there will be some distortion and residual stresses which will prop in, which are the defects or quality issues eventually, which can be addressed using simulation. So the whole manufacturing process can be virtually simulated, and process parameter can be optimized upfront in the design cycle.
Okay, understood. So there is a interesting question on chat, and my next question was also similar, and it was going to Mr. Mansin. So I was going to talk about the vehicle dynamics that change with electric powertrain. And what can you talk about the role of new materials and how the lightweighting approach changes when we come to electric vehicle design?
Yeah, so first of all, the dynamics of electric vehicles should not be theoretically different than the IC engine when it comes to driver, because the maneuvering, the ride of the vehicle, handling of the vehicle has been contributed not just by powertrain but also by the complete architecture of the vehicle, including the vehicle mass, the suspension characteristics, of course, the width, length of the vehicle, and then comes to the speed of the vehicle, etc., etc. So the problem came in EV vehicles is basically the battery location, battery mass, in proportion to the rest of the architecture of the vehicle, and the conflict with, as I said earlier, the range of the vehicle, where you want a lightweight vehicle. Traditionally in IC engines, the CG of the vehicle is to be very, very important while designing the vehicle, so that the major part of the ride and handling comfort was being achieved by lowering the CG. In electric vehicles, that comes naturally by design, because people try to put the battery as down as possible, below in the frame, etc., etc. But I have seen some vehicles where it has been shifted on the roof as well of the four-wheelers in order to save the space, etc. And that is a big challenge for rollover for this, the safety of the vehicle. and of course the maneuverability of the vehicle, role of the vehicle, etc. So in such specific categories, there needs a lot of simulation done upfront in order to make sure the ride parameters of the vehicle are being optimized with different locations, different distribution of the masses involved in the vehicle. At the same time, the uniform drive or the power which has been given by the electric vehicle without any transients, without any jerks, because typically electric motors are being driven with a pulsating electric current, and then it works on electric magnetic forces, and then it goes to the transmission. So there are good chances that there are big transients or jerks in the vehicle when you do sudden acceleration, decelerations, because the response, and that then gives uncomfort to the customer, to the vehicle. So there are many methods at design level you have to work on, taking out these pulses from the response of the electric vehicle, and then finally then whilst down to the architecture of the vehicle, where you have to optimize the ride and handling or the dynamics with respect to vehicle weight. And that's where the unique materials would come into picture. The torsional strength of the vehicle, the bending strength of the vehicle, these are the basic fundamental strengths of the vehicle are important to be achieved. Like in IC engine vehicles, traditionally, we try to achieve good torsion stiffness, good torsional dynamic modes, above some road inputs, above ride and handling issues like a wheel off, etc., etc. So by reducing the weight of the vehicle, this probably would be difficult in case of EV. So that's where you have to do multiple simulations to optimize the stiffness of the suspension, optimize strength of the body, strength of the frame, and that's where and of course the crash. Crash is a very critical requirement, and if you go to meet a 5-star crash or safety level, etc., you need a very strong body and frame, and which is again against your range because of weight. So the materials coming out of chemistry, which is like other plastic reinforced materials, other chemical materials, which are being now evolved very well in order to absorb the crash. So those integrating well inside the body, also using alternate materials, aluminum, some alloys, and these reinforcement materials for crash is a way to reduce the weight of the overall vehicle by maintaining the performance in dynamics, crash, etc. Squeak and rattle, of course, as IC engines as going out, which we used to say are noisy things, but we evolved IC engines NVH quite nicely. But those remaining noises of the IC engines were masking unwanted noise from body, unwanted noise from frame, unwanted noise from suspension. My experience in the new EVs, there is a big issue in squeak and rattle. That's because there are a lot of unwanted noise has been surfacing. And that has to do with also material selections, the damping of the materials, the joining of the materials, how they complement each other when they rub against each other, how the non-similar or dissimilar material joining in the manufacturing, either rivet, etc., was that give strength, the buckling of the vehicle materials. So all in all, I think the approach of using the alternate materials, but doing a lot of simulations upfront in order to look at the hard points, architecture of the vehicle, distribution of the battery mass, getting the proper uniform drivability is a key to make sure that you get a light vehicles and well-performed vehicles in EV.
Okay, thank you, sir. That was very important. Thank you. Bhavnesh, so AI and machine learning are the buzzwords, and in any industry you go today, you will see everyone is doing AI, everyone is doing ML. But in simple terms, can you explain to our audiences what role can artificial intelligence and machine learning play in EV design? How can it make the life easier for product development teams?
Okay, so it's mainly to do with data analytics with a lot of information what we have what to make out of that data. That's where AI ML can play a role. With that's one part of it. From a simulation point of view, it can help in reducing your solution time significantly, which I'll be talking on in the later presentation as well, on how a reduced order model can be used using AI ML methods and achieve the same level of accuracy in much lesser time of solution time. So that's been one of the bottleneck for the digital twins as well. So when we talk about digital twins, it's the digital representation of a physical subsystem. And this digital representation is mainly a simulation model, what you have. So you cannot have a much complex simulation model running in, because there is a real-time data exchange which need to happen. So that's where the reduced order models, which run much faster than the conventional FE models, what we run, is needed. So that's one part of it. And data analytics, as I said, is the key usage of AI ML here, and how efficiently you can use that data to take an augmented decision in your product development is what AI ML helps in.
Sorry. So Dr. Mukherjee, from your experience as an OEM, I would like to understand where all has simulation tools and digital tests have helped Omega Seeki in its product development. Where have you specifically found the most use of such tools in your company?
See, I started looking at EVs way back in 2015, around that time. And, somewhere around 17, 18 onwards, we started seeing these EVs coming into the market. Unfortunately, EV in India came through the low-end Chinese e-rickshaw, which were imported into the country, and they were running particularly in Delhi NCR, etc. So we right from the beginning we were clear, or rather I was clear, that we will not go by this route, even if it means making quick money in or other money in quick time. So we always wanted to make something which is robust, high quality, etc. And we collected a lot of data. We benchmarked these vehicles. We also imported vehicles from China to see, what is the vehicle configuration, quality of the basic construction, for example, the welding quality, painting quality, etc. And we benchmarked, we collected a lot of data. Then we came up with our vehicle. And I would like to tell you, for initial 2 years, we did not sell anything, because everybody was saying that your vehicle is, high priced, and how will you compete with a low end Chinese vehicle selling at 70,000 rupees or 80,000 rupees, etc. So we have gone through that. But our sort of view was very clear right from the beginning, that we will only put up a robust, high quality vehicle in the market. And fortunately that happened. Slowly the sales built up, etc. So I think the answer to your question is, the tools like the vehicle architecture, and also the powertrain development, we participated with Viria, for example, our powertrain supplier, using Dana powertrain. So we participated with them to make a efficient powertrain, because that time, there was no powertrain maker in the country. All the powertrains, everything was coming. China. So we had to do that initial heavy lifting, if I may call. And that is where this whole simulation, prototyping, testing, etc. helped us to benchmark the vehicle and what is available in the market. Also, our competition was with IC, like CNG, for example. So we benchmarked that, and we came up with our product configuration. So on the product design side, the simulation, etc. helped us. Unfortunately, we did not know about digital twin, etc. that time, but whatever tools are available on the product, on the component simulation, the FEA analysis, etc. that is what we did. And we sort of, with whatever knowledge or experience we have from our IC engine days, we brought that to the table, and we set up the manufacturing line accordingly to ensure there is a foolproofing. So auto industry, for example, uses FMEA very widely. So we used FMEA, failure mode and effect analysis, to see what can go wrong. We simulate that. I think that is where on the product quality, it really helped us. And also we captured a lot of data, which, in future would help us, like the driving pattern, usage, conditions, ambient conditions, and also the state of health of battery, etc. And each customer has its own way of using the vehicle, even though the vehicle is a commercial vehicle, three-wheeler, and mostly it is used in the last mile. But customer A uses it in a particular way, customer B uses it in a different way, the loading pattern is different, the commodities are different, etc. So we collected a lot of data. I'm not saying that we have used everything, and we have employed some heavy duty data analytics, etc. No, but we have a data pool which can be used going forward and make the product better. So I think just to summarize, if I would to your question, it is that the product design and the whole efficiency of the powertrain was done using these kind of tools.
Understood. Thank you, sir. So I'll ask, being another OEM, I'll ask the same question to you, Shresht. How have these tools helped you in designing your product, or also maybe accelerating your production and design?
Yeah, so when you come late, you have this advantage that you can capitalize on the more technology that is available in the market. As Dr. Mukherjee was saying, that digital twin and all that was not available back when he started, but right now we are working on it. In fact, we are working closely with Hexagon as well to getting some simulations done for, in fact, getting the software for simulations for welding and all that. So that definitely reduces the time to go to market, because as Mr. Bhavnish was also saying, that when the product is even more mature, then the cost of changing or making some changes in the product is very high, and that again sends you back to the drawing board and take care of all the components, because in electric two-wheeler specifically, you have that fixed size where you can only play a little bit. So that is what definitely that helps us in setting up our manufacturing facility, product, everything overall. The technology grows, it helps in reducing the time to go to the market, at the same time simulating all the real-time conditions, what can be the worst cases, what can be the best cases, and simulating in between all the range of it, and then implementing into the product and bringing the best product out in the market. So as Dr. Mukherjee was also saying, that getting the product from China or some other country and rebranding and selling it, or trying to work on it, it's very difficult, because it was not designed to function on Indian road conditions, according to Indian road conditions. So that's definitely there. And apart from that, we have a connected vehicle. So real-time data we'll be getting from the vehicle. That helps us improve a lot of things. And for the future products, it gives us the riding pattern of different parts of the country and different age groups, and we can segregate the data accordingly. And that helps us bringing out better products for better tomorrow.
Understood. Thank you. Thank you so much, gentlemen, everyone, for sharing your knowledge, your thoughts and insights with us. I think a very productive panel discussion where everybody, I learned a lot during this. So thank you so much for doing this. Next, so there are a few questions already come in the Q&A box, and there are some on chat as well. So as panelists, please feel free to type answers to any questions if you find time in between. And otherwise, we will anyways take the questions in the Q&A session. Next, I will invite Bhavnish to kindly share his screen and talk about how Upfront Simulation can help address the e-mobility design and manufacturing challenges. Over to you, Bhavnish.
Yeah, thank you. Let me know if you can see my screen.
Yes, Bhavnish, please go ahead.
Thank you. So my topic today is on addressing electric vehicle design and manufacturing challenges through digital validation or simulation, what you mean. So let me start with who we are. Hexagon is a global leader in sensor software and autonomous technologies. We are committed to empowering an autonomous future. So diving into the topic of discussion today, if you look at the EV market, we discussed in the panel as well, the growth which is anticipated is huge. So we are looking at almost 5x sort of a growth in next 10 years. And there are almost 600 odd EV new models which are planned by major OEMs, also startups. So we are clearly seeing that BEVs have taken a lead, and that seemed to be very much obvious today that BEV is the way we're going to go ahead with. But yeah, the technology which is used for the battery, the e-motors are changing, are evolving. So that's an area where a lot of changes are happening. But these kind of disruptive changes are happening in such a short period of time. So are we ready for it, or is the industry ready for it? What sort of disruption it would cause is a question which we need to think about. So before getting into today's topic of addressing the e-mobility's design and manufacturing challenges, this slide highlights on how an EV is different from a conventional ICE engine vehicle. So if you look at these parts, these are some of the new parts which are coming into your electric vehicle. So e-motor, the driveline, what is used, power electronics, a lot of it, the materials which are used because of the addressing the range issues, and also from a performance point of view, there are a lot of anisotropic materials which are being used. Composites have been used. Also the battery technology, cabin interior, Mr. Mansingh talked about the challenge with the acoustic what we had with EV, because the masking effect in the IC engine is gone. So the BSR bus squeak and rattle becomes an issue with EV. So cabin interior comfort is another becoming an important aspect to address. So let me talk about the key design and manufacturing challenges for e-mobility today. These are some of the key challenges, not all. So first and foremost, which used to be the range anxiety issue, but looks like the industry is addressing this challenge, and we are seeing a lot of development. Last week, we heard about the Mercedes announcement of a single charge high level of range which it had. So how simulation can help here? So some of the areas how we can address range anxiety, other than the policies, having a lot of the charging stations, from a simulation or a design point of view, what are the areas where we can add value is on powertrain optimization, battery thermal management, lightweighting, alternate material exploration, and also the innovation with the tire rolling resistance. The second point is on the manufacturing and quality assurance. Now with new components coming into the EVs, the way they are manufactured, the expertise, the skill needed to manufacture them is missing. So that's becoming another one big challenge there on manufacturing of these subsystems, and also using latest manufacturing techniques like additive manufacturing, or using dissimilar materials and joining them together. So the conventional approach of welding them might not work. Can I use adhesive? Can I use rivets? How would be the strength? So those are some of the challenges. Digital twins, as we've discussed in the panel discussion, and also the companies like Simple Energy, where Shresh just talked about, they are using the latest of technologies, and also the existing OEMs are moving towards best of manufacturing facilities what they have. They're moving more towards Industry 4.0. So for improving the productivity and efficiency, they're using a lot of smart manufacturing solutions. So that's another area of interest for EV development. Third is on the driver and passenger experience point of view. So when a customer is purchasing a electric vehicle is expectation on the comfort side and other features like advanced driver assistance system, infotainment, telematics is quite high. So addressing them is again another third challenge which I wanted to highlight. And the final one is on the safety and the vehicle performance aspect. Safety, we have discussed now in the panel. Yes, there are a lot of safety related challenges which can be addressed through simulation, which I'll be talking on the coming slides. So, and also when we move to electric vehicle, the basic expectation is the vehicle performance should not be less than or as compared to IC engine, if not better. So we have to ensure the acceleration, torque vectoring, vehicle dynamics aspect, noise, vibration, and harshness, durability of the vehicle. So that need to be addressed. So these are the 4 areas where simulation can significantly add a lot of value. Now, I highlighted this on why simulation first or why upfront simulation is needed. So if you look at, this is a very interesting chart out here to emphasize the importance of upfront simulation. So it shows that how the cost is committed as the design matures and the flexibility to the change. So the flexibility to the change is very high in the initial stage, and the cost committed is also very high. So any mistake or any wrong decisions in the early design phase will cost you more, and also will not let you change, because as the design matures, the change would be difficult or very expensive. So that is where, so if you look at this chart, then what is the challenge? So at the concept design stage, if you have to take any decision, the amount of information you need is very limited. That is where simulation can play a role. And that is what we are highlighting here on how upfront simulation can help. So with simulation, without even having a proto, you can generate a lot of what if scenarios. Innovation can happen in that concept design stage. And that is where you have a lot of flexibility to change around and play around with the design, and also will help you to reduce the cost a lot. So moving on to what are the key CAE or simulation solutions specific to electric vehicles. If you take the key subsystems like e-powertrain, the kind of noise generated from it, though it is not very noisy, the whine which comes out of electric powertrain is very irritating. That need to be addressed. From a battery point of view, battery thermal management, cooling optimization, battery structural safety, as we discussed, the batteries are mainly at the bottom of the vehicle, and when a vehicle goes on a bump, impact load which can short circuit a battery should not happen. So the battery structure should be strong enough or designed to take such a loads, if any. And also from a body structure point of view, how different dissimilar materials are joined together. Interior aspects, as I said, cabin comfort, torque vectoring, and also with e-mobility, there's also expectation of it being smarter. So how do we at least get into some level of autonomy into our two-wheelers and four-wheelers today? So that's where tools like virtual test drive can help you in designing these virtual scenarios and evaluate what if scenarios, the edge conditions, on validating your advanced driver assistance systems, advanced rider assistance systems upfront. Similarly, for two-wheelers, most of the concept is same, but again, there are something very specific as well for two-wheelers. And one of the requirement is if a company whose USP is the sound or thump of the vehicle, then when they move to electric vehicle, the thump is lost. And as a rider, I love riding vehicle which can create a good sound. So to address that sort of challenges, it's not a challenge, it's to address customers' requirements. So there are a lot of companies looking at simulated noise or creating a signature noise of vehicles. That's something, again, we're working with a lot of two-wheeler companies on that area, not only two-wheelers, four-wheelers as well. As you know, the kind of sound a Ferrari can make, it cannot, any EV cannot beat that, right? So how do I address that sort of a customer segment is also something which we need to see. So safety and all is paramount, performance, safety, and value add is another aspects where simulation can play a big role. So let me take some of the key components of your EVs and talk about it on how simulation can help. So powertrain being almost like an heart of your EV. The challenges are from the durability, NVH, efficiency, and architecture aspects. These are some of the target ranges which are given. But from complete holistic development of e-powertrain point of view, we have solutions which can address the architecture point of view, efficiency, dimensional quality, thermal management, CNC aspects can be optimized, fatigue life estimation, and also these e-motors, these electrical components emit their electromagnetic field of their own, which need to be shielded well so that the other electrical components would function well. So EMI shielding or electromagnetic interference is becoming another key area in electric vehicles which need to be addressed. So here again, we can explore different materials which can provide this sort of EMI shielding. And finally, the kind of noise generated from electric motors. So talking about noise, so e-powertrain, the core thing what industry is talking about today is, one is how do I make it more efficient, the thermal management challenges. The other is on the noise aspect as well. So we have workflows in place on how we can address this sort of issues from powertrain thermal management, and also from a noise from the electric motor as well. As I said, this might not be of high decibel, but the whine is a irritating noise which can irritate a lot of passengers within the vehicle. So that need to be addressed as well. So how are we uniquely placed, or what sort of solutioning we put together is, we are trying to connect three important parts of a product development as of any electric vehicle subsystem or a vehicle as a whole. So design and validation is where you do a lot of concept designs and try out in your virtual environment. And once that is done, that information is passed on to the manufacturing aspects where you act on what information you have from a design and validation. You actually manufacture that. Once that is manufactured, you ensure that it is as designed. Using our metrology devices, we ensure that the quality of these subsystems are as designed. So if there is any deviation with respect to the design, that information is then passed on to the design cycle. So this whole loop can be automated where you would have less difference or no difference between what has been designed and what has been manufactured. So based on that theme, if you look at each of the important subsystems, we have workflows from design and optimization, production and quality inspection point of view for each of the key important subsystems like electric motor, drivetrain, and also battery. So So from a battery point of view, again, we discussed a lot about all the issues, challenges, what we are facing today. This is a topic of very high interest in our country, at least these days. So if you look at this chart here, it says that what should be your optimum temperature for the battery to be performing at its ideal condition. So that's your 16 to 25 degrees. Operating temperature is from 0 to 35, and storage temperature can be minus 20 to 45. So we have challenges for low temperature as well as high temperature. Low temperature has little power and low efficiency and high internal resistance, and at high temperature, high battery degradation and risk of thermal runaway. So whatever you're seeing here today in India is not new. We've globally, this is a model or image of Tesla, which had happened a few years back. So this has happened in the past. It's not new, but how do we mitigate these sort of incidences? That is where simulation can play a big role. So from an experimental test point of view, first is you definitely should have a strong, rigorous standard for evaluating these subsystems, which are very much safety critical. So from an experiment test point of view, the key challenges here, it takes a long time. You need to have a prototype. It's a bit expensive, and you need to have a suitable test facility and all those kind of challenges here. That's where numerical simulations can help you with less effort and model preparation time. We can set up these workflows for you where you can quickly test out the battery system for the validation plan what you have for the battery system what you have. Similarly, that was from a thermal point of view, but there could be other challenges for battery pack manufacturers on how these battery packs can be manufactured. So as I said, from a manufacturing process simulation point of view, we can add a lot of value by helping the design process to be first time right, and also innovate at an early design stage. Again, ensuring the quality within the part is another important aspect. So these parts, most of the time, if you want to see the inclusions and other defects within a battery, you need to cut it open. So that's where computer tomography plays a role. So this animation, what you're seeing here, is of computer tomography from a software called Volume Graphics, which is us, which shows all these variations within and inclusions within your battery structure, which will help you to identify them without breaking it open. Similar workflows for battery and fuel cells as well. We have these workflows built in for most of the key subsystems. Moving on to another important topic, which is material. I believe that material will play a significant role in the electric vehicle development, not only from lightweighting aspect, but also from the performance aspect. So definitely from a range enhancement point of view, there is a lot of focus on using unconventional materials, or industry is looking beyond just metals today. So there are also performance plastics which can do much better than metals today and can be much lighter as well. There were few challenges of mass production and repairability, which kind of being addressed today to an extent. And also, when I talk about material, it's not only about the external body or load carrying members, it's also about to increase the energy density and charging time of a battery. We can also explore various battery materials which can be used, or the enclosures, battery packaging, EMI. All those aspects can be addressed using virtually simulating them in the design cycle. Okay, this is about the manufacturing process simulation. There was a question on this which I discussed. Yeah, this is what we can do if you take any manufacturing process from machining, forming, forging, stamping, welding, heat treatment, or even the costing studies can be done in the design cycle, ensuring that when you manufacture the part, it's first time right. So we can ensure that quality by optimizing the process parameters. Well, with electric, there's also expectation that the vehicles should be much smarter. That is where our advanced rider assistance system, autonomy, or advanced driver assistance system comes into play. We have solutions which can help you build such ADAS or ARAS systems and validate them using our solutions from various other, from a physical real world measurement systems to the digital twin simulation, where you can simulate various scenarios on and try out catch out the edge case where the vehicles are really seeing any threat from on how it need to. So it's basically how you're training the AI within your autonomous vehicle on under a particular scenario, how a vehicle need to react. That can be trained, which used to take years in physical testing, today can be done in days. So that's the progress we have made in validating autonomy or advanced driver assistance systems or advanced rider assistance systems. This is about AI. We did highlight this as well on how AI can help you take augmented decision with a lot of information from manufacturing, design processes. This is not specific to EVs. It can be generic as well. There are companies which are building cars, bikes, scooters for years, and they have a lot of data sitting there somewhere on how they what challenges they face, how they addressed it, and all those aspects. And that how to use it is something where AI and ML can really help. And also, as my fellow panelists mentioned today, the vehicle is so smart that it's collecting all the information on how the rider behavior and all that aspects, which eventually need to be crunched, and some information out of it need to come out in a augmented way. So that's where AI and ML plays a role, and that's how it helps you. The other important aspects, as I highlighted, is on the simulation aspect, on how reduced order models can help you. This is one of the example of battery short circuit analysis of a vehicle going on a bump, and there is an impact at the bottom, and because of which there is a voltage which shoots up, and then the short circuit analysis is done. So this analysis is done in a explicit third-party explicit solver. But then if you look at the output here, what we are seeing is temperature distribution, voltage history, and the deformation. So if you look at how much time simulation has taken and how much time a reduced order model simulation has taken, significant. It's almost 95% of time has been reduced. But don't look at it as an option or as a option to overcome these conventional simulations. But imagine that if you're running a design of experiments where large number of simulation need to be run for such a scenario, and each run, as you know, explicit scenarios take a lot of time. So instead of 24 hours of run time, if I can do a DOE case within 15 minutes, that's a great time saving, right? So almost 95% of time can be reduced. And as you can see in this slide here, the accuracy level is not lost. So from 0.88 mm to 0.86 mm, you can manage with that. So similarly, if you look at the voltage differences. That's also very close. So from maximum temperature, what you're seeing here is 89.3 to 89.1. So that's manageable, but the amount of benefit what you get by building such reduced order models is significant. That's 90-95% in some cases. So as you can see, the solution time in FEM as compared to our AI/ML program has been highlighted here. Finally, on our applied solutions offerings, this is a consultancy division of Hexagon where we do from the scratch concept design. Not even before building a concept, we can also do a market research and find out whether a new entrant, it makes a business sense for him to get into that market or not. From the market research to the concept design and development, detailed design, and proto development and testing, till the manufacturing process optimization for mass manufacturing, mass production, is what our team has this capability. They've done 2,000 odd projects. We have a global team which is sits out of our UK office, where these are some of the areas where their expertise lays in. So e-mobility point of view, it's transmission, electric machines, power electronics, control systems, and system integration. These are some of the successes which have been highlighted. And if I highlight some of the case studies, these are some of the successful projects which we have delivered. This is a hybrid passenger car rear axle electric drive unit. Again, the customer entering electrification market with a new product range required engineering design support for a rear axle drive unit for hybrid passenger and car application. Another development of a bespoke BEV, electronics, hardware, and control software, which was developed for an SUV. This was again developed within a short span of time of 12 months. To 35-ton heavy duty bus and truck platform. Again, the customer wanted to start with their electrification journey with a clean sheet of paper, intending to design a modular platform for their electric drivetrain solutions to replace legacy diesel solution. So this is something which I highlighted. So what we've achieved here is 10% more efficient solution than previous direct drive powertrain, including 1/3 mass reduction, 1/3 size reduction, and 1/3 unit production cost reduction. This is what most of the industry guys are looking for. Similarly, this is another project on a e-motorbike demonstration. Gate train optimization, another project which was delivered for a US motorcycle OEM, NVH assessment for an Indian OEM. So these are some of the projects which we have delivered so far. Have much more to show, but we have limited time. So I'll be stopping my presentation here, and I'll be happy to address any questions which you may have. Thank you. Thank you all.
Thank you, Bhavnesh, for that excellent presentation. Thank you so much. So yes, we do have a lot of questions coming in from panel discussion, and also some specific to your presentation as well. So we will quickly, so we only have 15 minutes left, so we'll quickly jump into the Q&A. So first question I can see in the Q&A box is, there's a question, is it good to model the 3-wheeler or 2-wheeler considering the mechanical aspects first, using some software, and compare the results with the prototype tester? And will it be an economical approach, and what kind of software can be used to do this?
Sorry, I did not get the question, Priyakshi, if you can.
Sure. So this is the 1, 2, 3, 4, fifth question in the Q&A box. I will read it out again.
Okay.
Is it good to model the three-wheeler or two-wheeler, considering the mechanical aspects first and using some software, and compare the result with the prototype tester? Whether it will be economical and what software will you suggest?
So I really don't know what your end goal is. If you just want to use mechanical systems, are you talking about an electric vehicle here? If it is, then yeah, there are many tools. So from a tool point of view, it's not a single tool which can be used for mechanical design. There could be tools like Nastran or Adams, which are used for vehicle dynamics aspect, for structural performance aspect, like torsional stiffnesses or other stiffness evaluation. We have tools like Nastran, which can be used. So it depends on what sort of validation you're doing. And even if you're just taking the frame, there are so many things which can be done on a frame. So I'll be happy to connect with you in person and understand what exactly you're trying to do and how I can help you.
Right. So Bhavnesh, can you share any contact details if somebody wants to get in touch with Hexagon after the event?
Okay.
If there is an email address or a phone number that you can share.
Sure, I'll drop it in the chat box.
Yes, yes, please. Another question related to simulation is that in EVs, we see more multi-physics simulations are being used, considering electromagnetics, thermals, and interdependence along the vibrations and high frequency noise compared to the ICE vehicles. So does it mean that the simulations for EVs are more complex and time consuming as compared to ICE?
Yes, they are to an extent, yes, I would say, because there are multi-physics at play. And also our simulation is getting mature to address such challenges. Back then in IC engines, we were not, though there were areas where multi-physics analysis were done, but I see more areas, like to give an example, if it's a electric motor noise, what we need to do as an outcome. There, it's not only the structural force which is at play, there's also electromagnetic force which need to be considered. So electromagnetic simulation need to be done, and that force also need to be considered. So like that, there are multiple physics which are coming in, and for more accurate results, it's better to consider as a co-simulation approach.
Okay. I'm taking a couple of questions from the registration form that we received, and again, I'll come back to the Q&A box. So one question was regarding the recent fire incidents. Can these digital tools help with tracking the quality of battery pack while it is in use and its real-time thermal behavior?
Okay, before I pass it on to others, I would just like to say this is one of the applications where digital twins can play a role. So digital twins is about collecting real-time information, and then Internet of Things connections where sensors can pass on this data to us on making a sense of, or predictive maintenance of these systems can be done through digital twins.
Okay. I would like to, if Shresh, you can comment on this, and if something like that you are planning with your vehicles, because recently the thermal incidents have gained so much negative press, and rightfully so. And so this is really a concern. And I've had actually some of my friends call me and say, hey, I was thinking of buying an electric two-wheeler. Should I reconsider? So I just want to know from your side, as an OEM, how much is it possible to collect this real-time data and use it to, at least for this use case, where you can avoid accidents?
So yeah, simulations do help you get the data out of the vehicle, but again, you cannot avoid physical testing validation, because that is the most important part. Simulations let for example, if on a scale of 0 to 10, they'll help you get to 6 or maybe 7, But for that three, you have to do the physical testing, validation, and all the conditions when you're talking about selling the vehicle across a country where the temperature ranges, the road conditions vary, the riding patterns also vary. So multiple checks and barriers need to be implemented in the process of designing, and then simulating, and then testing, validating physically before putting the vehicle into the market. So definitely that helps a lot. But as I was telling you that before, people used to make 500 prototypes to get that feel of the vehicle and get that perfect vehicle out. But with simulations and all that, that reduces your number of prototypes to, let's say, 50 or maybe 100. So that helps a lot.
Understood. Mr. Kumbar, if you can take the next question. It's again it's from Mr. Bharat, and he's asking to improvise the dynamics of the vehicle. What improvements are evolving in the design of powertrain, EV powertrain?
Yeah, so I think I would probably connect with him. It's little vast subject, and what he exactly mean by improvising the dynamics because of the powertrain. So typically dynamics, as I explained earlier, is a multi-dimensional aspect. It could be ride, it could be handling, it could be maneuverability, it could be the performance of the vehicle in terms of acceleration, deceleration. So I guess when he talk about powertrain, he definitely talks about the speed related things, acceleration, deceleration, the jerks and smoothness of that. And that needs a lot of preparation even before the system speccing for powertrain. And we go into the system modeling for that, wherein you work on the input requirements, output requirements with the 1D tools, with the data, and see that you run the vehicle with the system as smooth as possible without any transients in the power delivery or the torque transmission. So I think that's where you need to work on multiple facets. Of course, from the current homogeneity, electromagnetic fluctuations which you would get, and how efficient the transmission design in order to step down the speed and step up the torque gradually without any non-linearities in between. So if that's the aspect of the question, that's typically the answer, wherein a lot of things can be done upfront, and mostly focusing on the powertrain torque transmission and the motor efficiency and transmission efficiency. On the other side, I think, as I already explained, if it's on a vehicle level, ride and handling, maneuverability, etc., it's a global thing wherein we need to work on a full vehicle model, distribute the CG, work on the suspension stiffnesses, etc., which very close to what we do traditionally. More, I think, it's on the e-powertrain.
Okay, understood. Bhavnesh, we have one more question from the registration form, and that is, are there any simulation tools available for EV charger and charging system design?
Yeah, so it's not about having the right, if we have a specific tool for that. It's about what challenges we are trying to address from a charging ecosystem point of view. We are working with a lot of charging infra guys as well, where the focus is mainly on the if the focus is on the thermal issues, we have solutions which are focusing on that. If it is the structural rigidity, we'll be using tools which are relevant to that. So it depends on what areas are of the design we are addressing using our simulation.
Okay, understood. And there's again one on how about battery thermal management system and cooling? Can all of these specific areas, can we have simulation for these as well?
Yes, definitely. This is one of the key areas where simulation is used today in EVs. And as I showed in one of the slides, we have done a lot of work in that space. We'll be happy to connect with anyone interested in that space, and we can get into the details of it.
Bhavnesh, you have shared your ID.
Yes.
Okay, you mistakenly shared it only with hosts. Let me just put it for everyone. 1 second. So I'm putting Bhavnish's email address on chat. So any questions we are not able to take in this in just 5 minutes. And if you want to have a deeper technical discussion with Hexagon, please feel free to email bhavnish.adhikari@hexagon.com. Bhavnish, one more question from Mr. Swapnil, and he's asking that it's apparent that from recently published papers, traditional AI ML models do not find suitability for physics simulation. And there is a trend towards mixing physics with AI and ML. Do you have any comments on the same?
We are actually, the model what we have is physics-based models which we are using along with AI ML, and I agree to you to an extent that it has to go hand in hand, and I'll be happy to connect with you on and discuss in detail on what we have to offer here.
Okay. I'm just quickly, so Shresh, there are a couple of questions around battery chemistries. And there is one that says now there is this trend that we are moving to LFP because it is a safer battery. So are we saying like it's absolutely safe, or are we just talking in comparison? Can you offer some clarity here?
So majority of the industry is moving towards LFP majorly for two reasons. One is the cost and availability of the raw materials. So it is easily available when compared to NMC, and others definitely the flammability question is lower than NMC chemistries. But again, it's a trade-off between energy density and power delivery when compared to NMC. LFP have lower energy density, but are definitely are safer. But I guess majority of the reason, the major reason why industry is moving towards LFP is because of the availability of raw material and cost.
Okay, understood. I'm also sharing on chat Archana's email address and her contact details. So Archana represents Solize, which is a partner for Hexagon. And if you are interested to talk more about the solutions and understand the technology in more detail, please, you can get in touch directly with Archana as well.
Thank you, Shresh.
Yeah, thank you. So I think we are almost, there are a couple of questions which are repetition or have been covered during Bhavnish's presentation. So I think we are in a, I'm just, give me 1 minute. I'll quickly run through the new questions that have come. If we can take one last question.
Actually, we have one question about the lithium-ion battery. We've asked, what is the future of lithium-ion battery going forward with the raw materials of lithium-ion under stress globally in recent times? And also interest in sodium-ion battery gaining traction. So what is the outlook of the nation towards the battery in the Indian EV industry with regards to this at current times?
So I would request one of the panelists to please share the views on lithium ion and also sodium ion, as we hear is an upcoming technology.
So to answer to that, sodium ion technology to start with, it's again not commercially available as of now, and any technology to come into commercial viability takes a decade or so, right? So even if you're talking about sodium ion technologies, we don't have any model as such where you can just take it forward and commercialize it and bring it to the production. And also the time of any product to get to the market, you cannot compromise on the safety feature of it, because sodium again is a highly flammable material. So all those things, a lot of testing and validation will again go into it, and a lot of R&D also it requires, right? At the same time, yeah, raw materials for lithium ion batteries is something that everybody is facing challenges with. But I feel with coming out of the COVID era, I think that we will be able to capitalize on better supply chain opportunities and build better technologies for the future. But right now, I see that lithium ion technology, LFP and NMC are the only available options for now.
Right. But Shresh, we also hear about LTO time to time now.
Yeah, LTO, some companies are still working on it. But again, it's again the trade-off of cost versus energy density and the space constraint. So all those things, it depends on different use cases for different kind of vehicles. So again, some people might go for LTO, some people might go for LFP, but some people go for NMC as well. So all those things play a very important role while determining what kind of chemistry or what kind of battery pack that you want to use for.
Understood. Understood. So I would like to thank all the audience members, first of all, for asking good questions and making this a productive, engaging session. And again, I would like to thank all the panel members, Bhavnish, Mansin, and Mr. Shresht. Dr. Mukherjee had to leave. He had a schedule clash, and Archana for helping set up the event and managing everything. So thank you, everyone. Have a wonderful evening. We will put the recording of this session on YouTube at EVreporter channel in a couple of days. So if you want to revisit Bhavnish's presentation or any parts of this talk, you can, we will be sending out an email when the video is uploaded. So thank you so much.
Thank you.
Thank you, Priyaksha. Thank you for having us.
Thank you.
Thank you.
Bye.